Okay, the 3.1 practice number 2 video solutions, what I'm doing now. This really was just a kind of a review assignment, reminding you how to simplify square roots and simplify square roots of quotients. Okay, so not a real big deal, but we'll go through a couple examples. So the goal here when we're simplifying square roots, our goal is to get as much outside of the radical as possible. So we're always looking to see what's the biggest perfect square that divides evenly into the number in the square root, right? And so we're just going to, if you don't have this written in your notes, write it in your notes. I've got it on the front of the board, or the front of the room, but this would be a good thing to have. And it's easy to create anytime you need it. All we're doing is just looking at all of the integers, through 10 is probably good enough. All of the integers 2 through 10 squared. So 2 squared is 4, 3 squared is 9, 4 squared is 16, etc., all the way down to 10 squared is 100. So that's what we mean by perfect square. And so what that's really telling us then, the fact that 4 is a perfect square is telling us that the square root of 4 equals 2. And the fact that 36 is a perfect square is telling us that the square root of 36 equals 6, for example, right? So what's the biggest perfect square that divides into 81? How do we look for that? Well, first of all, you always want to ask yourself, is the number in the radical a perfect square? And in this case, yeah, it is. And so the answer is just plain old 9. What about something like this, square root of 5? Well, if we go back and look at this list here, is 5 on the list? Well, no, it's not. So then if 5's not on the list, the next step would be to see, is there a perfect square factor of 5? And so if the number's not on the list, then you can always start at half of the number and work your way up the list. Well, half of 5 is 2.5, which is below 4, so there's no place to go. So the answer is we can't simplify that. The simplified form is just the square root of 5. There is no perfect square. No number from that list will divide evenly into 5. Okay, what about something like this? Square root of 32. So what's is 36 or 32 on the list? No, it's not. 32 is between 25 and 36. Half of 32 is 16, so we'd start with 16, and that's jackpot. 16 is a perfect square. So we could rewrite this then as the square root of 16. We always want to put the perfect square factor first. And I even put a circle around it to remind myself that that goes first. And 16 times what is 32? 2. So we would break down the square root of 32 into the product of the square root of 16 times the square root of 2. And why did we put the perfect square factor first? Because the square root of 16 is equal to 4. So this just becomes 4 times the square root of 2. And so once again, our strategy was to get as much out of the radical as possible. Well, we did. The number in the radical used to be a 32, but now we've whittled it down to where it's only a 2. We can't go any further than that. Okay, and then so what about this guy? So we can do this one quickly. What's the biggest perfect square factor of 72? Well, it's 36, but what if we didn't see that? What if we thought, oh, well, 9. 9 times 8. Okay, even that would be okay, because if we broke down the square root of 72 into the square root of 9, which we recognize to be a perfect square, times the square root of 8, well then that would just equal 3 times the square root of 8. But then we'd have to ask ourselves, okay, well now we've got an 8 under the radical. Can I go further? Well, yeah, 4 goes into that. So I could write the square root of 8 as, let's write the square root of 8 as the square root of 4 times the square root of 2, and the square root of 4 becomes a 2. So then I just end up with 3 times 2 times the square root of 2, and 3 times 2 is 6. So my answer is just 6 times the square root of 2. We could have gotten there in one step, though, if we had just recognized that 36 is the biggest perfect square that goes into 72. Right, if we had looked at our table here and said, square root of 72 equals, well, 72 is not on our list. Half of 72 is 36, though, and that is. And so we could have written this as the square root of 36 times the square root of 2, which is 6 radical 2. Either way, that'd be easier to do it that way. Okay. What about if we have quotients? Let's look at some examples. So something like this. So there's a couple additional steps we got to do here. Okay, so first thing we can do is we can ask ourselves now, underneath the radical, can I reduce the fraction 16 over 81? You know, before I even start worrying about anything else, just ignore the fact, just look completely inside the square root at that fraction and say, can I make it simpler? No, I can't. There aren't any common factors of 81 and 16. So then what? Well, then the next step would be to split this apart into separate square roots. So I'm going to break it into the square root of 16 on the top divided by the square root of 81 on the bottom. And then I'll see if I can simplify either or both of those. Well, yeah, this one works out great. 16 is a perfect square. The square root of 16 is 4. And 81 is a perfect square. The square root of 81 is 9. And so my answer is just 4/9. Okay. What about 50 over 8? Okay, well, can I simplify that fraction underneath the radical? I can. 50 over 8 reduces to 25 over 4, and that makes things much easier. Then when I break this apart into the square root of 25 over the square root of 4, we just get 5 over 2. And that's my answer. Okay. Same kind of thing here too. If I divide 32 over 50 each by, or 32 and 50 each by 2 to reduce that fraction, I end up getting the square root of 16 over the square root of 25, which is just going to be 4 over 5. So we got, those are all pretty similar. Okay, finally, something that's a little different. What about one like this? Square root of 100 over 50. Okay, so that's one that ends up being 100 over 50 reduces to square root of 2, and I'd be done. Okay, but let's do a little different one. Let's say we had, so that's the answer to the one that was given to you, but what if this had been reversed? What if this, and was it reversed? I did that right. Yeah. So, what if instead we'd had a little harder problem? I kind of lucked out on this assignment. What if we'd had one that was like, let's say, the square root of, oh, let's say 40 over 100. Okay, so now we could simplify that fraction, couldn't we? We could write that as, let's see, what's the biggest number that goes into both 40 and 100? Well, 20 does. So I could rewrite that as the square root of 20 goes into 40 twice, and 20 goes into 100 5 times. So that makes it a little bit easier. I get the square root of 2/5. Then I would have to break this apart into the square root of 2 over the square root of 5. But here's the important point that I wanted to illustrate. I want to find a problem that illustrated this. So now what do? We can't have a radical in the bottom. We called that a stranded radical in class. Remember what you do whenever you have a radical that's stranded on the bottom, because I can't simplify that any further. The square root of 5 I'm stuck with. There's no perfect square factor of 5. So once I simplify the denominator to the point where I can't go any further, if I've still got a stranded radical, it's really simple. What I do from there is really simple. I'm just going to multiply both the top and the bottom by whatever the stranded radical is on the bottom. And the reason I do that is because a square root times itself is the same as a square root squared. And so that undoes the radical sign. The square root of 5 times the square root of 5 is automatically 5. The other way you can think about that is the square root of 5 times the square root of 5 is just the square root of 25. Also just 5 though, either way. To me it's a lot easier just to think about it this way though. You always know that when you multiply a radical by itself, it undoes the radical. But what do you get on top? Square root of 2 times square root of 5 is square root of 10, and I can't simplify that because there's no perfect square factor of 10. And so that would be my final answer. Okay, pretty good. We're done.